Afternoon, students.
పంపించు వాడికి చెప్తుంది.
Good afternoon, students. So now in today class, so far you have to completed the frequent item sets, and what are the frequent item sets you have to use with the algorithm. So frequent item sets, what are the patterns and what are the algorithms you have to use it in frequent item sets? Apply the algorithm, FP growth algorithm. So those are all algorithms you have to discuss, and which patterns are interesting or not interesting. Evolution, pattern evolution methods, and pattern mining. So constraint based frequent pattern mining. These are all concepts you have completed in last class. And before classes, we have to discuss the regarding to the classification and what is the classification, decision tree induction, base classification methods, and rule based classification. Bayesian belief networks, classification by back propagation, support vector machines. These are all concepts you have to complete it in previous classes. So now in today class, we have to discuss with that cluster analysis. This is a very important and external point of view. Cluster analysis means generally whatever the data we have in all over the world, the data for the data centers we have to represent it as dots. So all over the world, a particular region dots we have to group it as a one cluster. Grouped as a one cluster. And that is simply you call it as clustering is a process of grouping a set of data objects into a multiple groups or clusters so that objects within the cluster have the high similarity but are very dissimilar to the objects in other clusters. Actually, clustering is that is the grouping of set of data objects. So here that is regarding to the clustering. Similarities, whatever the data objects you have to group, that all data objects must be in the form of similar objects. Those data objects are similar objects. Dissimilarities and similarities are assessed based on that attribute values describing the objects and often involve the distance methods. Clustering as a data mining tool has its roots in many application areas such as biology, security, and business. Regarding to that, clustering అంటే సింపుల్ గా మీరు చెప్పాలంటే all over the world we have the data centers. So each data center you have to assign as one point data point. So one particular region, all data centers we have to represent it as one cluster. So whatever the data points we have to represent it as a cluster, that all data must be in data objects must be in the form of similar data you have. So here that is the cluster. How this similar data you have to analyze. That is the cluster analysis. So cluster analysis, simply you call it as cluster analysis is the process of partitioning a set of data objects into subsets. Each subset is a cluster. Such subjects or cluster is similar to the one another. Dissimilar to objects and other cluster. The set of clusters resulting from the cluster analysis referred as a clustering. So clustering is simply you can say that it is a process of partitioning of a set of data objects into subsets. That is simply call it as cluster analysis. So generally in the cluster analysis, you have to represent automatic classification. Generally here you can use a cluster of data objects can be treated as an implicit class. The clustering is called as automatic classification. So generally clustering is also, you have to call it as data segmentation also. Here data segmentation means in some applications, because clustering partitions large data sets into the group according to their similarity. Clustering is also be used as outlier detection, where the outliers may be more interesting than the common cases. Applications of outlier detection include the detection of the credit card fraud and monitoring and criminal activities in electronic commerce. That is the you can handle with this outlier detection. Example, exceptional cases in credit card transactions such as very expensive, infrequent purchases may be for the interest as possible fraudulent activities. So here we have to use clustering is also known as unsupervised learning, because the class level information is not present. For this reason, clustering is a form of learning by observation rather than the learning by examples. In data mining, efforts have focused on finding methods of efficient and effective cluster analysis in a large databases. Active aims of research focus on the scalability of clustering methods. The effectiveness of the methods are clustering complex shapes and types of data and high dimensional clustering techniques and methods of the clustering mixed numerical and nominal data in large databases. So generally here, what are the requirements of the cluster analysis? Mainly the requirements for the clustering analysis is first one is the scalability. Second one is the ability to deal with the different types of attributes. These are the requirements for the clustering. Scalability, ability to deal with the different types of attributes. Uh, these are the requirements for the requirements of clustering in data mining. Scalability, ability of deal with the different types of attributes. Discovery of the clusters with the attribute shape. Requirements for the domain knowledge to determine the input parameters. Ability to deal with noisy data. Incremental clustering and insensitivity to input order. Capability of clustering high dimensionality data. Constraint based clustering. Interoperability and usability. So these all are requirements for the clustering. And here you can represent the first one, scalability. Scalability means generally we have to represent it as many clustering algorithms work well. Small data set containing the fewer than the several hundred data objects. However, a large database may contain millions and billions of objects, particularly in web set scenarios. Clustering is on only a simple of given large data set may lead to the business results. High scalability clustering algorithms are needed to take requirements of the clustering. Ability to deal with different types of attributes. Many algorithms are designed to clustering in numeric data. However, applications may require clustering other data types such as binary, nominal, and ordinal data. And mixtures of these data objects. Recently, more and more applications need clustering technique for complex data types such as graphs, sequences, images, and documents. And third one is the discovery of clusters with the arbitrary shape. Generally, we have to call it as many clustering techniques. Algorithms you have to use it to determine the cluster based on the Euclidean and Manhattan distance measures you have to use. Generally, here environment surveillance you have to use it this one, and discovery of the clusters with the arbitrary shape. And the fourth one is the requirements for the domain knowledge to determine the input parameters. Generally, here you can represent the to provide the domain knowledge in the form of input parameters like desired number of clusters. You have to represent it here. And ability to deal with the noisy data. And the fifth one is the ability to deal with noisy data. Most real-world data sets containing outliers and are missing unknown erroneous data. That data you have to sensor readings you have to consider here. And the sixth one, incremental clustering and insensitivity to input order. In many applications, incremental updates may arrive at any time. Some clustering algorithms cannot be incorporate incremental updates into the existing clustering structures. And instead of having to recompute in new clustering from scratch. And the seventh one, capability of clustering high dimensionality data. So here a data set can contain numerous dimensions or attributes. And eighth one, constraint based clustering. This is one of the importantly most of the cases we have to use this constraint based clustering. Real world applications mainly we have to use this one. May need to perform the clustering under various kinds of constraints. Suppose the job is choose by the locations for a given number of new automatic teller machines, ATMs, in the city. To decide upon this may cluster households while considering the constraints such as the city rivers uh, and highway networks and the types of number of customers per cluster. And the last one is the interoperability and usability. Generally, users want to clustering results to be interpretable and comprehensible and usable. That is, the clustering may need to be tried to in the specific semantic interpretations and applications. These are the totally 9 requirements for the requirements of the clustering. Clustering in data mine. So what are the orthogonal aspects mainly we have to use? Here we have to use the 4 orthogonal aspects mainly we have to use. Those are the partitioning the criteria, separation of clusters, and similarity method, and clustering space. These are the 4 orthogonal aspects for the clustering method. Overview of the basic clustering methods, partitioning methods. Generally, this is the basic clustering methods. Our first one is the partitioning method, and interact hierarchical methods and density-based methods and the grid-based methods. These are the 4 types of methods you have to represent the in clustering. See here, this table will represent the clustering methods. These are the 4 methods you have to use for the clustering methods. In the clustering methods, first one is the partitioning methods. Partitioning methods means generally mutual exclusive clusters of the specific spherical shape you have to use it here, and distance based also these partition methods you have to use, and may use the mean or midpoint to represent the cluster center. Effective for the small to medium and medium sized data sets you have to use here. In the partitioning methods only you have to use the small and medium data sets only you have to use. And the next one is the hierarchical methods. Hierarchical methods mainly you have to use the clustering is a hierarchical decomposition we have to use here. Cannot correct the erroneous measures of it. Many incorporate other techniques like micro clustering and consider object in cages. And the third one is the density based method. Can find the arbitrary shaped clusters. Clusters are dense regions of object in space that are separated by the low density region. Clusters density, each point must have a minimum number of points within the neighborhood. May filter or outliers. Grid-based methods use the multi-resolution grid that generally data structure you have to put in. A fast processing time generally you have to perform in grid-based methods. So these are the 4 methods we have to use in data mining, that is the cluster methods, partitioning methods, hierarchical methods, density-based methods, width-based methods, and each method characteristics also we have to represent it in this table. First one, partition methods. Partition methods we have to call it as simplest and the most fundamental version of the cluster analysis is partitioning methods. Generally, here you have to use the algorithm, partitioning algorithm to organize objects into the k partitions. That must be k is less than or equal to n. Partitioning methods, k-means algorithm generally we have to use here. That is the centroid-based technique we have to use. That is the formula generally. That is the centroid-based partitioning techniques uses the centroid of the cluster. E equal to summation of I equal to 1 to k. P belongs to CA. Distance of P comma C1 whole square. These are the k-means, generally k-means centroid based technique. So here we have to use in the partition methods. This is the k-means algorithm that for the partitioning the which is the where each cluster center you have to represent it as mean value of the objects is in the cluster. The k is the number of clusters and d is the data set containing the n objects. Generally, what is the output you have to get in? That's how to consider the method of the k-means algorithm. That is very important. See this diagram which shows clustering of set of objects using k-means method. That is the initial clustering. Then second case we have to this is the diagram which shows initial clustering and iterate final clustering. See these diagrams which shows how to using the partitioning methods for the final clustering. Partition that is using the k-means method. So first cases that is the set of objects using the k-means method. That is the initial clustering. Nearest points you have to represent the data points you have to represent it as initial clustering. And second case that is update the cluster centers and reassign the objects according to the k-means. That is the each are marked as a plus. So which is the plus, which is the minus we have to represent it here. The data point nearest to the centroid that is considered as a clustering k-means partition. So which is the nearest to the centroid that is considered, that is you have to represent it as in another cluster. So see here that is the initial clustering. Then again you have to update that the iterate and final clustering. So in partition method, we have to use the two types of methods. We have to use the two types of techniques we have to use. One is the K-means centroid based technique, and second one is the K-medoids. Medoids is a presentation of object based technique. These are the two types of techniques we have to use it here in partition methods. Partition methods, one is the K-means centroid based technique, and second one is the K-medoids. We have to use the another technique. We have to
తినకుండా ఎలా తగ్గుద్ది నిజమే తినకుండా ఎలా తగ్గుద్ది నీకు
K-medoids represent the object-based technique. The major drawback of K-means algorithm, for example, we have to take the 6 points of one-dimensional space having the values 1, 2, 3, 8, 9, 10, and 25 respectively. The visual inspection of imagine the points partitioned into the clusters 1, 2, 3, 8, 9, 10, and 25 is where the point 25 is excluded because it appears to be the outlier. If the k-means partitioning the values, you have to apply the k-means using k equal to 2. That is the 1, 2, 3, and 8, 9, 10, 25 within the cluster variation. 1 minus 2 whole square and 2 minus 2 whole square and 2 minus 3, 3 minus 2 whole square. Similar way, 8 minus 13 whole square, 9 minus 13 whole square, 10 minus 13 whole square, 25 minus 13 whole square. Totally 196. Give the mean of the cluster. Second mean we have to represent comparing the values. 1, 2, 3, 8 you have to consider. 9, 10, 25 is taken as another cluster. So which is the k-means computes the within the cluster variation. Compared to the 196, now you can perform the mean value is minimized. That is the 1 minus 3.5 whole square, 2 minus 3.5 whole square, and 3 minus 3.5 whole square, and 8 minus 3.5 whole square. And a similar way, 9, 10. So generally, in first case, you have to consider the 1, 2, 3 is taken as a one cluster, 8, 9, 10 is taken as another cluster. So it is whenever 25 is taken as an outlier. But actually, in the k-means, whenever you have to applying the partitioning method, the variation you have to consider the k-means you have to apply. The values are 1, 2, 3. 1, 2, 3 we have to consider, and 8, 9, 10 we have to 25 is taken as another cluster. So now we have to find out the k-means value, that is the 196 we have to get it. After 196 we have to getting the mean of the cluster we have to consider as a 2, and the mean of the is 30. Comparing the partitioning with the computers within the cluster variation, the mean value is 3.5. So you get the value 189.67. So that automatically the mean value you have decreases. So these are the two methods. So that is the partitioning around medoids you have to use here. See this diagram. It shows reassigned to the AI, reassigned to the or random, and no change for that, reassigned to the random. So data objects and cluster center and gapping after swapping we can do all 4 cases of cost functional k-medoids clustering. So these are the two types of methods we have to use in partition methods. K-means method, that is the centroid based clustering, and second one is the k-medoids. clustering. These are the two types of partitioning methods you have to use in cluster. In next class, we'll continue the hierarchical methods and density-based methods and grid-based methods. So this is up to now we have to complete the partition methods. These are totally 4 methods that we have to use in cluster. Cluster methods are totally 4 methods. One is the partitioning, second one is the hierarchical, and third one is the density-based method, and fourth one is the grid-based method. So in partition methods, we have the 2 types. K means centroid based clustering method. That is the technique we have to use. And the second one is the K medoids. These are the 2 methods we have to use in partitioning methods. So in next class, we'll continue the hierarchical methods. Thank you.